For as long as we've looked into the night sky, we believe the universe had a clear beginning. A single, blinding flash of creation, the Big Bang, marking time zero. Everything that exists, every atom, every star, every galaxy, all emerging from that singular point. For a century, that story has been our cosmic foundation. But now, the James Webb Space Telescope, humanity's most powerful eye in the dark, has started to whisper a different story. A story that suggests something may have existed before the beginning. Something older than the Big Bang itself. When James Webb was launched, it wasn't meant to rewrite cosmic history. It was built to look deeper, to capture the faintest light from the earliest galaxies, those born when the universe was still young, only a few 100 million years old. But as its golden mirrors opened and its instruments began to see, the light that reached it didn't behave the way we expected. Webb started detecting galaxies so ancient, so massive, and so developed that by all current models, they shouldn't exist. These weren't faint, primitive clumps of gas just beginning to form stars. They were organized, mature galaxies, fully structured, rotating systems appearing only 300 to 400 million years after the supposed Big Bang. In cosmic terms, that's the blink of an eye. Yet somehow, they already contain billions of stars, heavy elements, and even hints of complex structures. The light from these galaxies have been traveling for over 13 billion years. But what Webb was seeing didn't match the timeline we built our understanding on. Astronomers tried to make sense of it. Maybe the data was off. Maybe these galaxies were closer than they appeared, their light distorted in some way. But measurement after measurement, correction after correction, the evidence only grew stronger. These objects were real. And if the Big Bang really happened 13.8 billion years ago, these galaxies must have formed almost immediately. Too quickly, too smoothly, too perfectly for our current models of cosmic evolution. Something didn't add up. One of the earliest of these discoveries was a galaxy now known as CRS 93316. James Webb captured its light just months after becoming operational. When scientists analyzed it, they found something astonishing. It appeared to have formed just 230 million years after the supposed beginning of the universe. That's like a newborn infant running before it learns to crawl. And CRS 93316 wasn't alone. Soon, Webb found dozens more. Each one more massive, more complex, more impossible than the last. The deeper Webb looked, the more the universe seemed to contradict itself. Galaxies with structures that should have taken billions of years to evolve were appearing in an era when stars had only just begun to ignite. And it wasn't just galaxies. Webb found evidence of massive black holes, some weighing millions, even billions of times more than our sun, already existing less than 500 million years after Big Bang. According to our understanding of physics, there simply hadn't been enough time for such giants to form. It was as if the universe had a head start, as if creation began long before the event we call the beginning. For decades, cosmology has been built on the timeline the Big Bang provides, a framework supported by the cosmic microwave background, by redshift data, by decades of observation. Yet now, Webb's infrared eyes were peering beyond that light, seeing older structures where there should be only darkness. The implications are staggering. If these galaxies truly existed that early, our entire understanding of cosmic time may be incomplete. It could mean that the Big Bang wasn't the absolute beginning, but just one of many beginnings. Scientists are cautious, as they always are. They proposed explanations, new physics, faster galaxy formation, unseen processes of early star birth. Some even suggest the universe expanded differently in its early stages, accelerating growth far beyond what our models predict. But others are quietly asking a more unsettling question. What if the Big Bang was not the start of everything, but a transition, a phase shift from a universe that existed before? It's not a new idea. For decades, a few theoretical physicists have explored concepts like the Big Bounce, where the universe expands, collapses, and is born again endlessly, or the ekpyrotic model, where our universe is just one in a cycle of collisions between higher dimensional brains. These ideas were always speculative, fringe, almost poetic. But now, with Webb's discoveries, the poetry suddenly feels like data. We are staring at galaxies that should not exist, light that should not yet have been born, Matter arranged before there should have been time to arrange it. And perhaps that means the story of the universe didn't begin with an explosion at all. Perhaps the Big Bang was more like a door, opening from something older, something eternal. As Webb continues to scan the ancient dark, its instruments are also revealing another, equally profound mystery: the scale of our own home galaxy, the Milky Way. For nearly a century, we believed our galaxy was 100,000 light-years wide. Every diagram, every textbook, every map said so. But recent data from Webb and the Gaia spacecraft has rewritten even that. The Milky Way, it turns out, is not 100,000 light-years across. It's closer to 200,000, twice the size, and maybe even larger. If we've been wrong about the shape and size of our own galaxy, the place we live, the structure we studied for generations, how much more might we have misjudged about the cosmos beyond it? Because Webb's discoveries don't just challenge when the universe began. They challenge how we measure it, how we define it, how we see it. And if those measurements have been wrong, then everything, from the age of the first stars to the nature of the Big Bang itself, may need to be rewritten. As scientists recalibrate their instruments and rethink their theories, one truth is beginning to take shape. The universe may not be what we thought it was. Not a single, linear story beginning with fire and expanding into emptiness, but something larger, older, maybe even infinite. The James Webb Telescope wasn't supposed to find this. It was meant to confirm what we already believed. Instead, it opened a window to something deeper, a cosmos that may have existed long before the clock began to tick. And if that's true, then the Big Bang wasn't the start of everything. It was just the latest chapter in a much older book, one whose first pages are only now being revealed by the faint light of ancient stars. When the James Webb Space Telescope opened its golden eyes, scientists expected to see chaos, the messy, turbulent beginnings of a young universe just finding its shape. They imagined faint, flickering clouds of hydrogen, tiny, primitive galaxies barely held together by gravity, the first fragile sparks of light in an ocean of darkness. But what Webb found was order, far in the deep infrared, beyond where any human eye could ever see. The telescope captured galaxies so massive, so organized, that they appear to have skipped billions of years of cosmic evolution. Spiral-like structures, dense with stars, glowing with the unmistakable signature of heavy elements: carbon, oxygen, iron. Elements that should have taken eons of stellar births and deaths to create. And yet, there they were, shining brightly just a few 100 million years after the supposed birth of time itself. The images came in slowly at first. A faint red smudge here, a glowing cluster there. But as more data arrived, a pattern began to emerge. These weren't outliers. They were common, dozens of early galaxies, each defying our understanding of how fast the universe could possibly build itself. By the time the universe was only 2% of its current age, these galaxies had already matured. It was as if cosmic evolution had pressed fast forward. Scientists call them impossible galaxies, not because they break the laws of physics, but because they break our laws, our equations, our models, our timelines. Everything we thought we understood about how galaxies grow. To build something as large as the Milky Way, you need time. Stars are born in clouds of gas. They burn for millions or billions of years. They die in supernova explosions, seeding new elements, which gather again to form new stars. This cycle must repeat again and again, layer upon layer, generation after generation, before a galaxy can truly take shape. But these early galaxies appeared fully grown. The light Webb detected had been traveling for over 13 billion years. That means the galaxies existed when the universe was less than 400 million years old. In cosmic time, that's not long enough for even one full generation of massive stars to live and die. So where did all those heavy elements come from? To explain this, astronomers began to imagine new possibilities. Perhaps the first stars, what scientists call population 3 stars, were much larger than we thought. Maybe they lived fast, burned hot, and died young, flooding the early universe with heavy elements in a cosmic flash. Or perhaps something else entirely happened, something beyond our current physics, something older. Because if these galaxies really are as massive as they seem, They must have started forming before the Big Bang timeline allows. And that simple, haunting possibility is what keeps scientists awake at night. Webb's infrared eyes aren't just powerful, they're time machines. Every photon it captures is a message in the past, stretched and reddened by billions of years of expansion. But if the universe we see through Webb's mirror looks too mature, that could mean the expansion didn't happen the way we think it did. Or worse, that what we call the Big Bang wasn't truly the beginning of that expansion. Some cosmologists now believe that what Webb is showing us may be the relics of a previous cosmic phase, a universe that existed before the one we inhabit. In this view, the Big Bang wasn't a singular explosion, but a transformation, the rebirth of an older cosmos collapsing on itself and giving rise to a new one. A big bounce, not a Big Bang. In this model, the galaxies Webb is detecting could be remnants, echoes of ancient structures that survived through the transition. Their light, distorted by eons of cosmic rebirth, might be whispering of a universe far older than 13.8 billion years. It's a bold idea, but the data keeps nudging us toward it. When scientists map these early galaxies, they notice something else unusual. The distribution of matter wasn't random. Galaxies were already clustering together, forming cosmic filaments and voids, the same web-like structure that defines the modern universe today. But that large-scale structure should have taken billions of years to emerge. Gravity works slowly. It takes time to pull matter together, to form the filaments that stretch across the cosmos. Yet Webb was seeing those patterns nearly at the dawn of time. The structure of the universe appeared to exist almost immediately, almost as if it had been there before. The deeper Webb looked, the stranger became. It wasn't just that galaxies were too massive or too organized. Some of them appeared too bright. Their light output implied populations of stars far older than the cosmic clock allowed. Some even showed signs of redshift value so extreme that, by all logic, their light should not exist at all. It's as though Webb is peering into a time that shouldn't be visible, light that shouldn't have survived. And yet, there it is, quietly shining to the veil of creation. Astronomers are cautious, working to verify the distances and refine their measurements. But privately, many admit that if the data holds, it will force a paradigm shift as profound as any in the history of science. Because to make sense of these galaxies, something fundamental must change. Either the age of the universe, the rate of its expansion, or the very physics that govern how it evolved. Webb has forced cosmologists to confront a possibility few ever expected to face again. What if the universe is older than the Big Bang? The phrase sounds impossible, contradictory, but there's a subtle difference between older than the Big Bang and older than we thought. If the Big Bang was not the true beginning, then there may have been a universe before ours, contracting, collapsing, reborn. In that case, the light Webb sees could be the last embers of that ancient cosmos, a memory burned into the structure of space itself. And this isn't just philosophical speculation. Some mathematical models already predict it. Quantum cosmology, the study of how the universe behaves at its smallest scales, suggests that space and time may never truly reach zero. Instead, as a universe contracts, it reaches a minimum size, a point of maximum density, and then expands again. Each cycle erases some of the past, but not all. Tiny imprints of the previous universe may survive, encoded in radiation, gravity, or the motion of galaxies themselves. James Webb, with its unmatched sensitivity, may be the first instrument capable of detecting those imprints. If even one of the early galaxies it observes turns out to predate the cosmic microwave background, the afterglow of the Big Bang, then the entire framework of modern cosmology will need rewriting. It's a breathtaking possibility. And yet, as revolutionary as it sounds, it's strangely poetic. The idea that the universe is not a one-time event, but an eternal rhythm, a heartbeat of creation and destruction, echoing forever through time. What Webb is revealing is not chaos, but continuity, patterns that repeat, structures that endure, light that refuses to fade. And perhaps that's the most haunting truth of all. Because if galaxies can exist before the beginning, then maybe there was never truly a beginning at all. As the telescope continues to gather light from the edges of time, scientists are turning their attention closer to home, to the Milky Way itself. For if we have misunderstood the birth of the universe, perhaps we have also misunderstood the nature of the galaxy we live in. because new data now suggests that even our own cosmic neighborhood is far older, larger, and more mysterious than we ever imagined. And what the James Webb and Gaia telescopes are uncovering about the Milky Way might just hold the key to understanding not only how galaxies grow, but how universes are born. For as long as humanity has looked to the heavens, we believe we understood the shape of our home. The Milky Way, a grand spiral of light, roughly 100,000 light years across, spinning gently in the cosmic dark. Every diagram, every textbook, every digital simulation agreed. It was one of the first things we learned about our place in the universe. We lived in a mid-sized spiral galaxy, a cosmic average in a universe filled with giants and dwarfs alike. But we were wrong. Recent measurements from the James Webb Space Telescope, the Gaia mission, and a collection of ground-based radio surveys have rewritten that story completely. The Milky Way isn't 100,000 light years wide. It's closer to 200,000, maybe more. It's not a small correction. It's a doubling, an expansion of our home on a scale so vast that our old models collapse under their own weight. For 70 years, astronomers have relied on a familiar method to measure the size of the Milky Way. They mapped the distribution of the brightest stars, traced the spiral arms as far as visible light could carry, and drew a line where the stars began to fade. That was the boundary, the edge of the galaxy. Simple, clean, understandable. Except galaxies are not clean shapes. They don't end abruptly, like continents meeting the sea. They fade, slowly, into halos of gas, dust, and dark matter. And much of that structure is invisible to ordinary light. We are inside this vast, glowing disk, buried 26,000 light years from its center. And from our vantage point, we can't step outside to see the whole thing. Imagine standing in the middle of a forest so dense that every direction looks the same. How would you measure its boundaries? That has been the astronomer's dilemma since the first telescopes were turned skyward. What changed everything was motion. The Gaia spacecraft, launched by the European Space Agency, began tracking positions and velocities of over 1 billion stars. Each motion was a clue, a tiny vector pointing to the true gravitational shape of our galaxy. Meanwhile, radio telescopes mapped hydrogen gas extending far beyond a visible disk, and Webb's infrared eyes pierced through dust that had long hidden the Milky Way's outer arms. When all the data was layered together, the picture that emerged was shocking. The galaxy didn't stop where we thought it did. It kept going and going. Rivers of stars, known as stellar streams, stretched outward like cosmic fossils, remnants of smaller galaxies the Milky Way had devoured long ago. Their orbits traced the true gravitational pull of our galaxy, reaching far beyond the supposed boundary. Some streams circled more than 200,000 light years from the center, double the old estimates. It was as if the Milky Way had been hiding half of itself in plain sight. The revelation went deeper than size. It reshaped everything we thought we knew about structure, gravity, and even our cosmic destiny. Because a larger Milky Way means a larger gravitational reach. And that means the Andromeda Galaxy, our nearest galactic neighbor, is closer to colliding with us than we once believed. But before we look ahead to that coming collision, we have to understand what makes our galaxy so much larger than we ever imagined, the invisible skeleton that holds it together. Scientists call it the dark matter halo. It's not just a halo of gas or faint stars, but an enormous sphere of invisible mass, extending hundreds of thousands of light years beyond the visible disk. This dark matter doesn't shine. It doesn't absorb light or reflect it. It interacts only through gravity, bending space itself. But its effects are unmistakable. For decades, astronomers noticed that stars on the outer edges of the Milky Way were moving far too fast. According to Newtonian physics, they should have been flung into intergalactic space. Yet they stayed bound. Something massive and unseen was holding them in orbit. That something was dark matter. And as our instruments grew more precise, it became clear that this invisible mass wasn't just a small addition. It was a majority. More than 90% of the Milky Way's total mass is dark matter, forming an immense halo that stretches far beyond anything we can see. Imagine an iceberg. The glowing spiral we recognize, the arms, the nebulae, the galactic core, is just the tip. The dark matter halo is the mountain of ice beneath the surface, vast and unseen. Measurements now suggest that the Milky Way's dark matter halo may extend 400,000 light-years from the center, possibly as far as 1,000,000. If true, it means that the true size of our galaxy could rival the space between us and Andromeda. In other words, the halos of both galaxies may already be touching, silently blending together in the darkness. The collision, once thought to be billions of years away, might have already begun in the unseen realm of dark matter. This discovery forced scientists to rethink what it even means for a galaxy to end. Where does the Milky Way stop and intergalactic space begin? Is it the edge of the visible disk, the point where stars thin to nothing? Or is it the invisible frontier where gravity finally loosens its grip? There is no clear answer. Galaxies, it turns out, have no true borders. They fade, gradually, endlessly, until one becomes another. And that realization carries a quiet poetry, because it means we are not living in a galaxy isolated by space, but in a vast continuum of cosmic influence, a gravitational sea without shorelines. The Milky Way does not float in emptiness. It merges softly into the great structure of the universe. As the data poured in, another mystery deepened. If the Milky Way was twice as large, it must also be far more massive. At least 4 trillion solar masses, possibly more. That's 4 trillion times the mass of the sun, most of it invisible. And yet, even with that immense weight, the galaxy spins faster than our models predict. Stars at the edge move at incredible speeds, some so fast they skirt the boundary of escape velocity, barely held in place by gravity. It's a delicate balance. One small shift, one fraction less mass, and entire swarms of stars would drift away into the void. Something about the way gravity behaves on these scales still eludes us. Perhaps dark matter isn't distributed evenly. Perhaps it clumps, forming hidden pockets of mass that stabilize a galaxy in ways we can't yet calculate. Or perhaps, as some physicists dare to wonder, gravity itself behaves differently on these cosmic scales. Whatever the explanation, one thing is clear. The Milky Way is not the quiet, average spiral we once imagined. It is a colossus, an empire of stars and invisible matter stretching hundreds of thousands of light-years into space. And that has consequences. If our own galaxy is twice as large, then every galaxy we measure might be too. Our entire cosmic map could be distorted, our sense of distance and scale subtly wrong. The universe may be denser, more interconnected, more ancient than we have ever believed. Because if we misjudged our own home, how could we have measured the rest of the cosmos correctly? The James Webb and Gaia missions are now revealing just how interconnected everything truly is. They're showing us that galaxies are not islands floating in a void, but nodes in a cosmic web of gravity, light, and dark matter. Each one blending into the next, their halos intertwining, their histories overlapping. A tapestry too vast for the human mind to fully grasp. It's a humbling revelation that even after centuries of looking up, we are only now beginning to see the place we live in for what it really is. A galaxy twice as large, a universe perhaps older than we ever imagined, and a cosmic story that refuses to stay still. Every new observation Webb makes, every motion Gaia tracks, every faint whisper of light that reaches us from the edge of time, they all carry the same quiet message. The universe is bigger, stranger, and far more ancient than our textbooks ever dare to say. And as we continue to measure the Milky Way's true size, we may also be measuring something deeper. The limits of our own understanding. In the stillness of night sky, it's easy to believe that everything above us is frozen in time. The constellations appear eternal, unmoving, a celestial map that has guided sailors and dreamers for thousands of years. But the truth, as the James Webb and Gaia missions have begun to reveal, is far more dynamic, far more alive. Our galaxy is not standing still. It is moving, twisting, colliding, and the slow dance has begun will end in fire and rebirth. For decades, astronomers have known that the Andromeda Galaxy, our nearest spiral neighbor, is drifting toward us. The two galaxies are locked in a mutual gravitational embrace, pulled together by forces that have been shaping them since the dawn of time. But new data, fueled by the revelation that both galaxies are much larger than we once believed, has rewritten choreography of that cosmic waltz. The collision has already begun. Not in the way we might imagine, no brilliant explosion, no shattering of stars, but in silence. The invisible halos of dark matter that surround both galaxies are now touching, intermingling, blending in the unseen depths of space. For hundreds of thousands of light years, the gravity of the Milky Way and Andromeda now overlaps. The boundaries that once separated them have dissolved. If you could somehow see dark matter, the night sky would look different. You'd see two titanic shadows, immense and formless, already merging. The faint glow of the Milky Way's halo press against Andromeda's, their invisible tendrils weaving together like mist. The first contact between galaxies doesn't happen in light, but in darkness. This revelation has profound implications. For generations, we believed that the Milky Way and Andromeda would collide roughly 4.5 billion years from now. But a larger galaxy means a stronger gravitational pull, a deeper reach into intergalactic space. With that new reach, the timeline shifts. The two galaxies will begin interacting far sooner, maybe in 4 billion years, maybe even less. That might seem distant, almost irrelevant to us. Yet in the story of the cosmos, it's already happening. Every particle of dark matter, every distant star at the galaxy's edge, already feels a faint tug of Andromeda's gravity. And in return, our galaxy pulls back. It's a slow-motion dance measured not in years, but in epochs, one that will reshape the night sky forever. When the collision finally becomes visible, it won't look like destruction. It will look like beauty beyond imagination. Andromeda will grow larger each night, a faint smudge becoming a glowing disk, then a magnificent swirl of light that fills the heavens. Two galaxies, each containing hundreds of billions of stars, slowly moving through one another. And yet, almost no stars will collide. Space is too vast. The stars will pass between each other like grains of sand drifting through an ocean. The real chaos happens in gravity. As the two galaxies intertwine, tidal forces will tear their structures, stretching spiral arms into vast ribbons of light that stretch for millions of light years. New stars will ignite as clouds of gas compress under the immense pressure of collision. The night sky will shimmer with newborn light, a billion suns blazing into existence across a galactic battlefield. Astronomers call this a starburst phase, a brief but spectacular period of creation. In that era, the Milky Way will no longer resemble the calm spiral we know today. It will be a storm of energy, dust, and light, a galaxy remaking itself. Eventually, the dance will slow. After perhaps a billion years of swirling, stretching, and merging, the two galaxies will settle into one. The elegant spirals will dissolve into a single, massive elliptical galaxy, rounder, smoother, quieter. And its name has already been chosen, Milkomeda, a fitting fusion of two ancient spirals that once stood alone, now reborn as one. For humanity, it's a distant future we'll never see. But the universe measures time differently. In the cosmic scale, this merger is already in progress. It's not a future event. It's a present one, unfolding slowly across billions of years. And if you look closely, if you study the faintest regions of the sky, where the edges of our dark matter halo brush against Andromeda's, you can already see the signatures of their interaction. Streams of stars, long and ghostly, reaching out from both galaxies, some torn from smaller satellite galaxies long ago, others pulled outward by the first whispers of the coming union. The James Webb Telescope has begun to map these tidal bridges, revealing trails of ancient stars that drip between the two giants like bridges of light. It's as if the cosmos itself is preparing for what's to come. And yet, even in that cataclysmic beauty, one question lingers. What happens to us? Will Earth survive the collision? Will the sun be pulled away, cast into the cold between galaxies? The answer, remarkably, is mostly comforting. The vast distances between stars mean that direct collisions are almost impossible. When the galaxies merge, our solar system will likely drift into a new orbit, perhaps farther from the galactic center, perhaps closer. The sky will change, but not our safety. By the time the final merger takes place, however, the sun will already be dying. In about 5 billion years, it will swell into a red giant, consuming Mercury, Venus, and possibly Earth itself. So while humanity may never witness the full collision, life elsewhere, or whatever descendants we leave behind. Might they will look up and see not one spiral galaxy, but two dancing across the heavens in slow motion. There's something poetic about that. The same universe that once birthed us from dust will end our night sky in beauty, creation and destruction endlessly repeating. And if the Milky Way and Andromeda are already merging in darkness, it means something even more profound. The cosmos doesn't wait for human timelines. It moves at its own pace, slow, deliberate, eternal. Every moment we live, every breath we take, we are part of that motion. We are passengers on a galaxy mid-journey, drawn toward a destiny written not in prophecy, but in gravity. When the merger is complete, Milkomeda will be a supergalaxy, a colossal luminous sphere containing perhaps 1 trillion stars. Its dark matter halo will stretch 1 million light years in every direction, encompassing everything that once was a local group. The night will glow brighter, yet emptier. No spiral arms, no gentle rotation, only the slow hum of ancient starlight fading over time. But that fading is an end. In the universe, nothing truly ends. Every merger gives birth to new stars. Every collision shapes new worlds. The energy release and destruction becomes the spark of new creation. And just as Webb has shown us galaxies that seem older than the Big Bang itself, perhaps the collision of Milky Way and Andromeda will seed structures that last long after our own epoch is gone. Maybe, in some far future, beyond even the lifetime of this universe, light from Milkomeda will travel across the cosmic dark, to be seen by another civilization in another time. They will look back, as we do now, and wonder what it all means. They will see the light from our galaxy's final act and call it ancient. Perhaps they will think it marks a beginning. Perhaps they will name it the birth of something new, because that's what the universe does. It ends, it begins, and it continues, quietly, endlessly. And right now, as we drift through the stars, we are living in one of those transitions between what was and what's coming. The James Webb Telescope wasn't just built to capture beauty. It was built to remind us of movement, of impermanence, of the truth that even galaxies live and die, and in their death, they create again. Somewhere out there, 2.5 million light years away, Andromeda is already reaching for us, and the Milky Way is reaching back. Their embrace has begun, silent, invisible, and unstoppable. The universe breathes, and we are caught in that breath. When the James Webb Space Telescope first opened its golden mirrors to the darkness, humanity expected answers. Instead, it gave us questions. Quiet, profound questions that stretch beyond the reach of time itself. We wanted to see the beginning, to glimpse the first light after the Big Bang. But what Webb showed us was light that seemed older, galaxies too massive, too complex, too ancient to fit the timeline we believed in. It revealed a cosmos that wasn't young and chaotic, but structured, mature, and impossibly familiar. And as those ancient photons reached us, tiny messengers traveling for over 13 billion years, they carried a truth both beautiful and unsettling. The universe may not have had a single beginning. It may have always been here, in one form or another. Everything we thought we knew about the story of creation begins with the Big Bang, a singular moment when time, space, and matter exploded outward from a point smaller than an atom. But the data doesn't sit still. It resists simplicity. And now, with Webb's discoveries and Gaia's measurements, a new picture is beginning to form. One that feels less like an explosion and more like an echo. If galaxies existed before they should have, if structures formed faster than physics allows, then maybe the Big Bang wasn't the start. Maybe it was a transition, a pulse in an eternal heartbeat. Some physicists call this the cyclic universe model. In it, the cosmos expands, cools, and eventually collapses under its own gravity, only to rebound again. Each cycle erases most of the past, but not all of it. Tiny imprints, the echoes of previous universes, survive the collapse and seed the birth of the next. In this view, our universe isn't 13.8 billion years old. It's timeless, a wave in an endless ocean. James Webb might be the first instrument sensitive enough to see those faint echoes, ancient galaxies that didn't vanish completely when the last universe ended, but instead carried over, reborn into ours, like embers surviving the end of a fire. If this is true, then what Webb is seeing aren't just impossible galaxies. They're memories, fragments of a universe that came before, and maybe, somewhere deep in their structure, hidden in the oldest light, there's a signature that tells us the truth, that the Big Bang was never beginning, only a new verse in an infinite cosmic poem. For the first time, we are beginning to sense what that poem might be saying. It speaks of galaxies that remember, of matter that recycles, of time that doesn't flow in a line, but in a circle. Every birth is a death, every ending a beginning, and this idea doesn't just live in theory. It's written into the very structure of our own galaxy. When Webb and Gaia revealed that the Milky Way was twice as large as we believed, the discovery didn't just redefine our home. It redefined our perspective. It forced us to accept that what we see is only a fraction of what exists. That darkness isn't absence, but architecture, the invisible scaffolding of reality itself. Dark matter, the mysterious substance that shapes galaxies, could be the key. It may be the remnant of previous universes, carrying mass and memory across cycles of creation. It doesn't shine, but it remembers. It forms halos around galaxies like invisible fingerprints, reminding us that nothing ever truly disappears. And if that's true, then the universe itself might be alive in a way we never imagined, not conscious, but continuous, not static, but self-renewing. Our galaxy, the Milky Way, is one expression of that continuity. It's not a closed system, but part of a larger flow, devouring smaller galaxies, merging with Andromeda, reshaping itself over billions of years. Even now, it's growing, reaching farther into the void, pulling new material into its gravitational field. Creation doesn't stop. It just changes form. When we think of cosmic history, we often imagine a linear story. First it was nothing, then something, then us. But maybe the truth is more like a wheel, endlessly turning, endlessly reborn. The Big Bang may have been the latest spark in an infinite cycle of expansion and collapse, light and darkness, order and chaos. It's humbling to think that somewhere, in the deep future, when our merged supergalaxy Mokometa begins to fade and cool, the same forces that once gave birth to us will act again. Gravity will slow expansion. Stars will die. Light will dim. And when the universe grows quiet enough, it may begin to fall inward, not an end, but a gathering, until everything collapses into itself, compressing, eating, igniting. And then, in a moment that's happened more times than we can imagine, it will begin again. Perhaps the next universe will see the remnants of ours the way we now see those impossible galaxies, faint, ancient, and inexplicable. And maybe they too will wonder what came before. Maybe they'll build their own telescopes, their own questions, their own quiet awe. The James Webb Telescope was built to look backward in time, but what it found may have looped time back upon itself. It has shown us that the universe isn't simple. It isn't young. It isn't finite. It is layered, eternal, self-aware through the eyes of those who look back into it. We, who evolved on a small blue world orbiting an average star, are not outside the cycle. We are part of it. The atoms in our blood were born in ancient stars. Those stars were born in older galaxies. And those galaxies may have formed from the ashes of universes long forgotten. In a very real sense, we are made of memory. The universe remembers itself through us. When we gaze into the night sky, we are not looking at distant places. We are looking at time itself, the endless reflection of creation, folding and unfolding over and over again. Every photon, every star, every breath we take is part of that ancient rhythm. The Big Bang was never a beginning. It was just one more heartbeat in eternity. And so, when the James Webb Telescope stares into the deepest darkness, it is not merely observing history. It is listening to the echoes of universes that came before, listening to the hum of infinity. Because in the quiet between galaxies, where light fades into silence, the universe is still speaking. It's telling us that there are no true beginnings, no final endings, only the flow of existence itself. The cosmos breathes in light and exhales shadow. It expands, collapses, begins again. It remembers, and so do we. So the next time you look at the stars, at that faint band of light crossing the sky, the heart of the Milky Way, remember this: you are not looking out, you are looking back. Back through billions of years of memory, through cycles of birth and destruction, through time itself, you are seeing what the universe once was, and what it will become again. James Webb has shown us that the universe is older than the Big Bang, because the universe never truly began. It simply is, endless, beautiful, and awake,